Okay, let's talk about the magnetic moment ratio of coils. Here's the question we are looking at. A to amp current is flowing through two different small circular copper coils. They have a radii ratio of 1 to 2. We need to find the ratio of their respective magnetic moments. And here are the options we have. Option 1 4 to 1, option 2 1 to 4, option 3 1 to 2, option 4 2 to 1. Let's get started with the solution. Step 1 is all about recalling the formula for magnetic moment. The magnetic moment, which we'll call M for a current carrying circular coil, is given by this formula, M equals Nia. Now for step 2, let's make sure we understand the variables in this formula. M equals Nia. N stands for the number of turns in the coil. I is the current flowing through it, and A is the area of the coil. Moving on to step 3, we need to express the area specifically for a circular coil, since that's what we have. For a circular coil with radius r, the area A is given by A equals pi r squared. In step 4, we are going to substitute that area formula into our magnetic moment formula. So we take A equals pi r squared and put it into M equals Nia. That gives us M equals Ni times pi r squared. We can write that a little more cleanly as M equals Ni pi r squared. For step 5, let's set up the magnetic moments for the two coils we are given in the problem. We have coil 1 and coil 2. We'll call their magnetic moments M1 and M2 their number of turns. N1 and N2 their current I1 and I2 and their radii R1 and R2. Using our formula for coil 1, the magnetic moment M1 equals N1 I1 pi R1 squared. And for coil 2, M2 equals N2 I2 squared. Step 6 is about identifying the information we are given in the problem and making any necessary assumptions. First, we know the current is the same for both coils. I1 equals I2 and that's 2 amp. Let's just call this current I. Next, the radii ratio is given as R1 to R2 equals 1 to 2. This means R1 over R2 is equal to 1 over 2, or we can say R2 is equal to 2 times R1. Finally, the problem doesn't say anything about the number of turns. So we'll assume the number of turns is the same for both coils. N1 equals N2. We'll just call this N. Alright, step 7 is where we calculate the ratio of their magnetic moments. We want to find M1 over M2. So we set up the fraction M1 over M2 equals N1 I1 pi R1 squared, or divided by N2 I2 pi R2 squared. Now let's substitute what we know. N1 equals Nn2 equals Ni1 equals I and I2 equals I. So M1 over M2 equals Ni pi R1 squared divided by Ni pi R2 squared. Notice that Ni and pi appear in both the numerator and the denominator. We can cancel those out. This simplifies nicely to M1 over M2 equals R1 squared over R2 squared. And we can write that as the ratio of the radii R1 over R2 all squared. We are on the final step. Step 8. We just need to substitute the radii ratio we were given and find the final ratio of the magnetic moments. We know that R1 over R2 is equal to 1 over 2. So we substitute this into our simplified ratio formula. M1 over M2 equals the quantity 1 over 2 squared. Calculating that out, M1 over M2 equals 1 squared over 2 squared, which is 1 over 4. So the ratio of their respective magnetic moments is 1 to 4. Looking back at our options, this matches option number 2. The final answer is 1 to 4.